in this class, we'll study what are the different properties of a system. So first, we'll see what is the definition of a system. A system is a set of elements or functional blocks. So that can be connected together to produce a output. So I have taken a continuous time system like this. So I have connected input. It is called x of t. So this is called a system. It has got different parts. So then it gives a different output, that is y of t. So for a discrete time system, it is called x of n and output is y of n, and this is called as discrete time systems. So now every system has got different properties. So let us see what are the different properties of a system. So start with it is a static and dynamic systems, time invariant and time variant systems, linear and non-linear systems, causal and non-causal systems, stable and unstable systems, invertible and non-invertible systems. Now we'll see what is the difference between static and dynamic systems. So first I will start with static. Static systems are also called as memoryless systems. I think this you have studied in your third sem. So in digital circuits. Okay, so a continuous system is said to be static or memoryless if its output depends only on the current input. So for example, so I have taken a resistance. So I am trying to measure the voltage across a resistance. You know that by Ohm's law, V of t equals R into I of t. So therefore, here the voltage drop across the resistance is depending on the current time input I of t. So therefore, it is said to be a memoryless system. Similarly, for a discrete time system, I have taken y of n is equal to 10 times x of n. So where 10 is a constant number, it gets multiplied with the input x of n, and here also the output is depending on the current value of n. So therefore, it is memoryless. So a system is said to be dynamic or with memory if its output depends on the past value of the input. For a typical example is a charging of a capacitor. So we know that V of t, so that is voltage across a capacitor is given by 1 by c integral minus infinity to infinity I of t dt. So it is typically an integrator system.
Start.
So here the voltage across the capacitor depends on present as well as the past values. So hence it is an integrator. So it is a system with memory. Now I have taken another dynamic discrete time system. X of y of n equals x of n plus x of minus 1. So now here the system is said to be dynamic because it is depending on the present value n and the past value n minus 1. So therefore it is said to be a dynamic system. Similarly, I have taken another example, y of n equals summation. Summation block is also said to be a dynamic system. If I expand this system, it will be x of n up to x of n minus 4. So therefore, it is a dynamic system. So all dynamic system or memory system or static system or memoryless systems. Okay, next is time invariant and time variant systems. So a continuous time system is said to be time invariant. It is very important if the time shift in the input results the corresponding time shift in the output. So I have taken an example. Y of t is a system output which is depending on some function. If I write f, it is said to be a function on the input x of t. So now what I will do, I will change the t value to some other value called as t1. So therefore this will be f of x of t minus t1 I will write. So if the time is changed in the input, at the same time output should also get shifted by the same amount. So therefore I have got y of t minus t1. So if I get output like this, so then the system is said to be time invariant. So similarly, for a discrete time system also, the shift in the input by k units should be reflected in the output. So therefore it is y of n minus k. So the time variant systems does not satisfy the equation. So 1 and 2. So that's why there are two kinds of system. One is time invariant and time variant. So now I have taken an example. So I have taken y of t equals sin of x of t, sin of x of t. So now let us take this example. So here I have changed x of t to x of t minus t1. So therefore this will be sin of x of t minus t1. So now that change I have done only in the input. So therefore I am writing like this, y of t comma t1. So that means the output when the time is changed by t1 units. So now, so when it is changed, so this will become y of t minus t1 equals sin of x of t minus t1. So therefore it is a time invariant system. So next I have taken x of t into cos of 200 pi t. So now here I am multiplying the input with a cos function. So this is called as function. So I am multiplying input with a cos function. Now here we have to be very careful. So I have to change only the time x of t here. So therefore I have taken f of x of t minus t1. So therefore this will be, I am changing only at the input side. So therefore it will be x of t minus t1 into cos of 200 pi. Ali 2 pi and you change it as 200 pi t. Okay, cos of 200 pi t. So now I will change t1 at the output side. So therefore this will be y of t minus t1. So ಈಗ output ಬರಿಬೇಕಾದ್ರೆ you have to shift the time by t1 units. Therefore I am taking input x of t minus t1 into this function is also time dependent. So ಅದನ್ನ output ಅಲ್ಲಿ ಮಾತ್ರ ಮಾಡಬೇಕು. Therefore I have taken cos of 200 pi into t minus t1. So now if you compare 1 and 2, they are not equal. So therefore the system is time variant. So these two examples I have given to show some of the properties of the system. So you please go through these notes. If you find comfortable, so then I'll start doing preparing the notes according to this method only, and I'll try to solve some more problems. Okay, thank you.